Hi, Marielle.
Yeah, hi.
Thanks for coming in Paris.
Yeah, nice to be here.
Join the YouTube channel Data by Design I've just created.
Yeah.
Today we're going to talk about, of course, data modeling. That's the topics for these interviews.
Yeah.
For people who don't know you yet, can you introduce yourself in a few words, please?
Yeah, sure. My name is Marielle. I'm based in Berlin, Germany, usually. And I work as a staff data engineer at a company called Paddle. Paddle is an online payments infrastructure company for SaaS businesses. It's based in the UK. But I wasn't always in the data and tech space. So before that, or before I started to work in data, I was an academic researcher in a field called applied cognitive sciences. So this is an interdisciplinary field that combines psychology and computer science to study how people structure knowledge in their brains and how people learn through some kind of technological interface. So my background, I also did a bachelor's degree in psychology, so I was always more involved in social sciences, which I think a lot of people find quite surprising because they don't automatically see the connection between technology and psychology. But I like to say that I previously studied how people structure knowledge in their brains, and now I help companies structure knowledge in databases. So yeah, that's why I'm here.
Welcome again. How did you get to the data modeling part? Because maybe some don't know how you can link data modeling and data knowledge. Did you start this journey at Paddle, for example?
I started, I guess, doing proper data modeling at Paddle, or at least I discovered the term data modeling, the data modeling world, as I started to work with our cloud data warehouse at Paddle. But I realized that I'd been doing that for other jobs as well. Just to maybe zoom out and talk about my career in general. So I had been a researcher, and then after my, towards the end of my PhD, I decided I didn't want to be a researcher anymore, and I wanted to work in tech because I was already involved in computer science and stuff like that. And this was in 2018, and then at the time, data science, the term data science was a really big buzzword, right? And all the companies wanted to do data science, and I'm like, yeah, I'm a psychologist, I'm a scientist, I can do data science. And then I applied for a couple of jobs that you said were about data science, and then I realized that many of these companies aren't ready for data science because they don't have the data to support it, or they haven't even started modeling their data to understand even the most basic KPIs of how many users do they have, how many active users do they have, and how many website visitors do they have. And so that's how I ended up being a data modeler, or a data engineer, or an analytics engineer. So many terms for the same thing, right? Because I realized that many companies hadn't even started with the foundations of their data. There was production databases, third-party data, and there needed to be a way to combine all of that in order to understand what the company is about and how the business was doing. And so I found my way into the tech world by finding that, by not doing what I wanted to do, which was data science, but finding something that was really useful for the companies that I worked for at the time, because they needed a place to start, and I think companies should really start with a good data modeling foundation. So yeah.
Yeah, that's very interesting, because I think we can see the link between data models and data knowledge, because finally models are knowledge.
Sure.
So you talked to me about the Paddle.
Yeah.
What is Paddle doing as a, so you said a SaaS payment platform?
That's right. So Paddle is works with SaaS businesses in order to help them develop their payments infrastructure. So I believe DataGalaxy is a SaaS business, right? So
totally.
So you know how difficult it is to run a SaaS business. First, you want to be able to develop your product. You want to be able to sell something that's good and useful to different users, right? But if you have a SaaS business, you need to have payments infrastructure. You need a way to be paid for the service that you provide, right? So there will be several gateways that you might want to connect to, like not Paddle, but PayPal and Stripe, all these payment methods that you want to be able to provide to your users. You want subscription management tools as well, so that you can accept recurring payments, and then you need to worry about what you're going to do if those payments fail. Taxes as well, if you want to sell your products to different domains. Just lots of things that you have to worry about, right? But Paddle wants to take care of all of that for SaaS businesses. So basically, one tool or one infrastructure, one platform for all of SaaS businesses' needs, so that the SaaS businesses can focus on product development, which is their passion and what they're best at. But Paddle is not just a payments infrastructure company; it's also what you call a merchant of record. So a merchant of record is basically it's like a reseller of SaaS products, which means that Paddle sits between the SaaS business and the user, and takes care of all tax liability, of currency conversions, and all of these, I guess, boring but necessary stuff in order for SaaS businesses to be able to, focus on products and not necessarily worry about whether they'll get in trouble if they don't pay their taxes properly in this territory or that territory. And that enables SaaS businesses to scale globally really fast. So that makes my job as a data modeler very, very interesting, which I'm sure we'll get to in a minute.
Yeah. Regarding the countries and the tax, of course, I imagine there are some big topics right here.
For sure.
So how would you describe in simple words or in a few words the what we call the reality of or maybe the processes that you have at Paddle and you had to create the model for? Yeah.
So one thing, I guess, to remember about if you're working with SaaS businesses is that you are dealing with recurring events that are happening at a regular interval. So SaaS businesses rely most of the time on a subscription-based business model, right? So you expect recurring revenue every month, every year, or however however it is that you plan out your subscription plans. And this is supposed to say businesses like marketplaces or like businesses like Airbnb, where the payment events are more transactional, so more like one-time payment events. So for me, I have to manage data models that have events that I expect to recur at a regular interval. We also have one-time events as well, but for the most part, we're interested in recurring events. And the other thing is we have two users at Paddle. We have the SaaS businesses that use the Paddle product, and then there is the user that purchases the product of the SaaS business that uses Paddle. And we're going to get to the terms on how to refer to those two different users in a minute, because it can get quite confusing. So that's how I would describe it in not so simple terms, I guess. It's never simple. It's just never simple. Yeah.
But really understandable. Thank you.
Yeah.
Regarding now let's say the internal stakeholders, because I believe at Paddle you are of course many employees. So
correct.
We have the users, and of course we have the internal stakeholders.
For sure.
So can you tell me who are they and what they are focusing on?
Yeah, sure. So at Paddle, there are two broad categories of analytical teams, or teams that deal with data. So one is the product and engineering teams. There is a dedicated product analyst for the product and engineering teams. And they're mostly concerned with monitoring product performance and finding different ways to improve features of the product. So they're closer to the product and the software engineering side of the Paddle business, whereas the commercial teams, they deal with the business side of things. So the ones that are basically closer to the bottom line of the business. So there is a revenue operations team, a growth team, finance team, and a customer success team. And those are the different stakeholders that I manage as a data modeler. Yeah.
Okay, and what is their focus? So for the product teams, you told me about the, let's say mainly the features.
Yeah.
Are there differences for the other teams?
Yeah. So the product and engineering teams, they want to use data to improve the product. And whenever they look at data, they always think of it from the perspective of the SaaS businesses that that Paddle is serving, or that are using Paddle. For the commercial teams, they are looking at things also from the perspective of the Paddle SaaS businesses that are being served, but also of the users of those SaaS businesses as well. So the focus is more of how can the SaaS businesses improve their business through the data that we provide, or that my team provides, whereas the product and engineering teams will think of how to make the experience of the SaaS businesses better when they use Paddle. Does that make sense?
Yeah, totally.
Yeah.
To start with the data modeling, are there some differences in their vocabulary or in the terms they use for defining, for example, users or as you told us? Yeah,
this is a very interesting question, and I wonder if other companies struggle with this as well. And I'm willing to bet that other companies struggle with this too. So, as I said, there are two main users of Paddle, right? There's the SaaS businesses, and there are the users of the SaaS products of those SaaS businesses. So, like I said, the product and engineering teams think of their work from the perspective of the SaaS business. So those SaaS businesses are called sellers by the product and engineering teams because they sell SaaS products, right? And their users are called customers because a SaaS business has customers, right? So I also prefer the term Paddle seller. So a Paddle seller would be a SaaS business using Paddle. Now, the commercial teams, they will think of the SaaS companies as our customers. So they call Paddle sellers customers. And the users of the SaaS products are called buyers because they buy from our customer. So this sometimes causes a lot of confusion, because depending on the dashboard or the data set that you're looking at, customer might actually be called seller or vendor sometimes, or buyer. You'll see buyer ID and you're wondering what is a buyer ID, but it's actually also customer ID. But yeah, we are working on making sure that those ambiguities are kind of sorted out.
And if I remember well, in your previous talk, there was also a question regarding the payment in itself.
Yes.
You had different terms about this?
Yeah. So this one is actually an ambiguity that has been solved. So Paddle is a payments infrastructure company, right? And so the term payment is, at least for the data model that I've created, was a deliberate choice. Versus other terms that might be a synonym for payments. So, for example, transactions. So sometimes, even like kind of when you just talk in your daily life, you'll say, maybe I made this payment or I saw this transaction in my credit card statement, that kind of thing, right? So when it came time to develop a payments model or a model for, to check whether, the money that goes through our product is going through properly, what do we call it, right? Is it a payment or a transaction? And me and a couple of my collaborators, including the product analyst and other engineers at Paddle, settled for the term payments because transaction actually means something else in the world of finance. So transaction in finance terms, at least from my understanding, I'm not in finance, but it could mean any event that will change the value of, or the balance of a ledger. And because we have a finance team, like we didn't want to use the term transactions just in case they already have an idea of what a transaction is. So, and also in our marketing materials, in our outreach, we refer to ourselves as a payments infrastructure company, which means that the business wants to look at payments data. So if someone goes and asks, hey, where can we find payments data for Paddle? I can just go and say, oh, it's in the payments table. So it's good for user experience as well.
That makes sense, thank you. Did you have some troubles with the countries, for example, or geographic payments?
Yeah, this is, I would say, probably one of the toughest concepts to nail down in my line of work. Since Paddle is, concerned with cross-border payments, which means, we as a business want to help other SaaS businesses grow their business all over the world, which means enabling payments in different territories and countries, right? But that also means that the concept of a country is very difficult to pin down in just one kind of simple sentence. So every time anyone requests any kind of country data, we have to ask them to be specific about the country that they want to see. So just to give you an example of how many different countries we deal with. So we all presumably have a credit card, and that credit card was issued by a particular bank. So one type of country data would be the country of the issuing bank, which should be the same as the country of the customer's credit card. So that's one. And then you'll have the seller's country as well. So seller meaning the SaaS business. But what is the SaaS business's country? Is it the country of their headquarters? So for example, DataGalaxy is the country then France. Or is it the country of that SaaS business's bank? I don't know where the bank of DataGalaxy is, but maybe let's say Switzerland. You have a bank in Switzerland. Is that the country of the SaaS business? That's one thing you have to consider as well. And then another country is the IP address at the time a purchase was made. So for example, if I were to buy, I'm in France right now, my bank, my credit card was issued by a German bank. So my credit card country is Germany. Now, if I make a transaction here, or a payment, is it a payment or a transaction? I'm kidding. But if I were to pay for something here in France, then the country of my IP address and the country of my card are different. And that may or may not be a red flag for my bank, because it's not the same. And the chances of fraud are higher when those two countries don't match up. So this is one of the most kind of difficult issues, or not issues, but concepts that we have to get right when we model data, or that we have to get right when we make reports for our different stakeholders. We need to know exactly what it is that they're looking for. And if they don't know what they're looking for, we introduce them to all of these different possibilities of a country, and then we work it out with them. Yeah, it's fun, lots of fun.
Yeah, sure. And as you stated, with the layer regarding the seller's customer, so if you ask for the customer's country, you have first to ask if it's the Paddle customer,
exactly.
Customer, seller's customers.
Exactly that.
Seller's customer's country. Okay, that's a lot of detail for just one question.
Exactly, yeah. I literally had to deal with this morning. So, yeah.
Yeah, so that's probably the good moment to talk about data modeling storytelling.
Yeah, it's a great book.
From Larry Burns.
Correct.
Yeah, that's something you advised me to read.
Yeah.
And how would you say it, this book helped you to create the models for the payment system?
Yeah, I just first of all, I have to say I love this book a lot because it echoes many of the concepts that I learned as a researcher in cognitive sciences. So it focuses a lot on creating data models and data sets as as common ground for all these different teams that work with data, right? And that's what I learned as well as a psychologist, is that to use artifacts and to use kind of, whether that's physical kind of drawings or kind of digital, artifacts to find a shared understanding for complex topics like payments in this case. So Larry Burns advises to start data modeling from a top-down perspective, which means that you start from the top, meaning the business. Let's say, in my case, I started modeling payments from the product and engineering perspective, because they were the ones actually who commissioned the model in the first place. And then I tried to understand payments first from their perspective. And once I narrowed that down, once I nailed that down, I reached out to the other teams that needed payments data to check whether their understanding of payments was the same or different from the product perspective. And Larry also talks about in the book the opposite of top-down modeling, which is bottom-up modeling, which is where you start from your data sources, whether that's a production system or third-party APIs, and then using production systems to model business models, which he claims is not a very good idea. It will make your job of data modeling quicker because, if you have a clean production database, you can just do a star select and, there you have it, the data models, just do some joins. But the likelihood of reusing that data meaningfully across different teams is less likely if you do it from that perspective, because you're not really thinking about the business. You're thinking about it in application terms, in system terms. And what the application spits out as data, it may not be what the business wants, right? So for example, our sellers table in the production system is actually called vendors. So it's like, even if that's just a simple kind of, you're just going to alias the column, it's fine. It might, cause a lot of confusion downstream closer to the business. So when it comes to the payments model, like I started with the product and engineering teams. Like I said, product and engineering wants to improve the product, which means that when it comes to payments data, they want to see how many successful payments are going through, but also how many unsuccessful payments are going through. You have a SaaS business, so you're familiar with failed payments and how that's a loss in revenue, and we don't want that, right? So product and engineering wants to be able to, figure out why payments are failing and be able to correct that. Now, the commercial teams, let's say our revenue operations analysts, they don't really care too much about failed payments because failed payments don't bring money. Only the successful payments bring money. So when they do revenue forecasting, they only need the successful payments, right? So in a payments model, if you have both unsuccessful and successful payments in that model, product engineering will be happy because they can do their job. And revenue operations is also happy because they can just filter that table to just get the relevant data that they want and leave out the stuff that isn't possible. So that is an example of top-down modeling where you create a model that is wide in scope, that encapsulates a shared understanding of a complex business entity or concept, and is highly reusable because different teams are served by one data model. So yeah, love this book.
And so I conclude that you have created only one data model for the different stakeholders?
For payments, yes. For now, it's only one model. However, in the future, when our systems are changing, maybe we have more gateway providers that we include, maybe that will change. Another thing I should probably point out is that, the payments model is actually a large denormalized table that different analyst teams can query from. And what we encourage in the data team is that other business teams build data sets on top of that wide model to narrow down the scope. Like I said, if like, revenue operations only needs successful payments, there's no reason for them to keep querying this big table because it's going to be, not very performant. They can just create a view on top of it or something. So in the end, it's not one big table per se, but it's maybe one big starting point, and it branches off to like different areas, but you can always trace it back to the same source. And I think this is really important for when, in the future, if conflicts were to arise. Let's say, this payment, for example, this paddle seller only has 100 payments in my table. Is there a problem like with the source? You can always trace it back to the same source. Or like, you don't have to like worry about the different ways that like people are joining tables on the cloud data warehouse, because it's already pre-joined for them in this one big denormalized table, which I know might be a bit controversial for the fans of facts and dimension tables. But yeah, I think it is really important to have this one big starting point in order to disambiguate complex concepts, and to have shared understanding and common ground between different teams.
Very clear. I'm
I know. I'm waiting for the. I'm waiting for the criticism. Like.
No. Criticism, just very interested to know more about this, because I'm a Snowflake schema guy, so very fan of dimensions. But I understand also that it's very typical to a specific understanding, and with all the synonyms and all the things you told us about regarding the terms, I believe it can be very simplifying for the analysts to have this one big table. And I propose that we dig a bit further in this data model. Okay, that's the magic of the video. So now we have the whiteboard.
Correct.
Would you mind draw for us the architecture and so that we can then dive into the model?
Yeah, sure. So we've at Paddle follow what you call the medallion system. I think it was created by Delta Lake, so many other companies would follow this scheme as well. So basically our raw data, let's say, I'm just going to draw a nice cylinder here. My apologies for the less than stellar drawing, but let's start with this database that we call Bronze. So the Bronze database is where we store all of our raw data from different sources. So we have data from our production systems, we have data from our third-party APIs, and they all land in the Bronze database. So this is unfiltered, untouched raw data. And then some magic happens, and then we have data moved over in a layer that we call silver. So silver is where we store our data sets or data models that have been cleaned, transformed, and verified by the data engineering team. So when I talked about the payments data set or payments model, that's a model in the silver layer. So we've taken our raw data from Bronze, did some transformations on it using dbt, and then stored it in silver. We have what comes after silver. We have the gold layer. So in the gold layer, we have business level aggregated data from the wide silver tables. So usually the data engineering team develops silver data sets. Like I said, these are like white tables that combine different data sources from Bronze. And the gold part, or the gold layer, is most of the time managed by the business teams. So they build views or tables on top of silver data sets to fit their very specific business needs. So an example of that would be, like I said, the product and engineering teams would look at the payments data set to understand successful and unsuccessful payments. The other teams that might not concern themselves with unsuccessful payments might want to create a gold table that filters the unsuccessful payments out. So for the most part, my team is involved with silver and business teams are involved with gold.
Thanks. As you know, I'm a very old dinosaur. And, could you explain me the difference that you may have between bronze, silver, and gold database with ODS, data warehouse, and data marts, as we used to define them previously?
Oh, right. So I might not know how they used to be defined previously, because to me, a data warehouse would be the tooling itself, which is Snowflake, BigQuery, and stuff. Our cloud data warehouse would then be Snowflake, right? And actually, these databases are called they're called data warehouses, actually. Now that I think about it, within Snowflake. But to the question of say what is a data mart in this scenario, I would say that both silver and gold are data marts. If you think of data marts as the part of the database that serves an analytical purpose, the data here is going to be used for analytical purposes. So silver would then be the data mart for business teams. This is where business teams should go to query data in order to fulfill some kind of analysis, right? And what they would then do is create a gold table. And that gold table is usually the data set that is under the hood of a dashboard. So we use Tableau at Paddle. So for the most part, Tableau dashboards would have a gold model underlying it. And those dashboards are also data marts in a way, just visualized. And those are used by other business people at the company who might not be involved in any SQL or any data analysis themselves, our C-suite. So this BI layer is basically there, and under the hood of it is in a way our data mart, or our gold data mart. But for our internal stakeholders, their data mart is the silver layer. So that's how, I guess, the new way of doing things that may or may not be in line with previous ways of doing things, which I have a high respect for, and I would love to I'd like to think that many of the things that I've done are based on all of those good work that the dinosaurs have made or something. Sorry, I hope I didn't offend anyone with that. But yeah, I think this is the system that works for the business that we have. Yeah.
Okay, and if we zoom in each of these tables, so database, I think that so in bronze it's just a copy of the production tables.
For the most part, yeah.
Yeah, and so for the silver and the gold part, that's where you have implemented the one big table?
So in the silver data, most of the one big tables, so multiple big tables really. And in between bronze and silver, there's a lot of transformations going on. In fact, I would say 99% of transformations are done between bronze and silver. But these transformations are hidden from the end user because we don't want to confuse people with this intermediate model says payments, this must be the payments table or something. So we kind of, we obfuscate that from the end user of Snowflake. But it's actually in this part of our architecture that we have something similar to facts and dimensions. It's only, of course, exposed to the data engineers that do data modeling in the silver layer, right? So I work with two other data engineers, and we all are building these silver data sets. And we also want to have common ground with each other. So we all refer to the same checkout table, for example. Checkout would then be, in this case, a dimension table. But this is not something that we necessarily have to expose to the end user because we don't want them to have to think about, what is checkout again? Oh yeah, that's one-time payments. It's different from subscriptions, which is recurring payments and that kind of thing. We just want them to see the part that says payments. Because like they can, for the most part, people want payments. They don't necessarily need to distinguish between checkout and subscription. So there's a lot of magic in here that I haven't drawn out, but like this is what matters at the end when it comes to data analysis. Yeah.
Okay, to continue to zoom into this data modeling, could you describe a bit more, in a more detailed way, the data modeling in one of these databases, silver or gold? For example, the payment table you talked about?
Yeah. So for the payments table, that sits again in the silver data warehouse, and that table is actually a combination of different data sources that have to do with payments at Paddle. And like I said, all of that sits in the beginning in the raw bronze database. So we have our, like, I'll just write it down here, our production or application database. So it's the ones that are managed by Paddle. And then we'll have third-party APIs as well. Third-party APIs. So because we are a payments infrastructure company, we have data coming in from different payment gateways like PayPal or Stripe, right? And so those data sources, they both deal with payments data, but they might not model payments in the same way. And it could be something as simple as how they flag a successful payment. So for PayPal, it might be that they have a column that says just success. It's called success, and it'll be true if the payment was successful, 0 if it wasn't. Maybe for another payment gateway, it'll be a string that says success, or like success with some, conditions or whatever. And these are the kinds of little, let's say, inconsistencies between the data sources that have to be reconciled in the magic that happens between bronze and silver. Because like I said, when it comes to our data marts, for our end users, we just want them to be able to identify the data that they need right away. And so that's why in the end, we just have all this magic that's happening here. And that's why in the end, we all just have this one big, nice table that combines all these different sources together in the silver layer. Because it's less of when you have facts and dimensions, you're joining these tables, right? Actually, for the payments data, it's a union of different sources. It's not just a join. And unioning, requires that you reconcile different field values. You need to conform the success flag from PayPal or Stripe or the production database so that they all kind of look the same. And that's a little bit harder to achieve than if you had a very seamless application kind of data schema that you can just do joins in, or you can train people to do proper joins in. But if I had a different preference for flagging successful payments and the other team has their own preferences, that can lead to a lot of inconsistencies in the results. So that's why as data engineering team, as the data modelers, we make the executive decision to model it in this way and to provide just a denormalized table so that they don't have to worry about how to do the unions properly. So hope that made sense.
Okay, very clear. And for you, what is the main benefits and who is going to benefit from this modeling pattern?
Yeah, so like I said, the silver database is the data mart for our internal stakeholders who use data for different kinds of analysis. And this is a really helpful system, like maybe I've covered already, to establish a shared understanding or common ground when it comes to complex business entities and concepts that the company should have alignment or agreement with. So we have this payments silver data set, right? Like I said, it's a wide table that business teams need to narrow down in order to fulfill their different analytical needs. So like, let's say our product analyst wants to understand payment acceptance. This is whether successful, whether there are unsuccessful payments going through our systems and how to correct that, right? So the product analyst might want to create a gold table for a dashboard in order to display this analysis. Payment acceptance. How can we improve payment acceptance of our payments infrastructure? And this is a dashboard that product and engineering can look at on a regular basis in order to improve product features, right? Our customer success teams also want to understand payment acceptance because our sellers want to understand their payment acceptance. So they might create their own gold model for that. So you'll have two, gold models that are essentially about the same thing, which is payments, but they have a slightly different focus, right? So maybe for this gold model, paddle sellers will be called sellers, like I said, because again, product and engineering teams need to take on the perspective of the SaaS business. In this gold model for the customer success teams, the paddle SaaS business that is being served might be called a customer. And their users are called buyers. And the names in either of these gold models will be different because it serves different needs for the business. But both are anchored on the same big data set. That's why if, say, customer success comes to product and engineering and said, why is payments for this customer lower in my data? Is it the same for your data? And they'll be like, well, is it for this seller? We have this number instead. And then those two teams can have a discussion about the conflict that they noticed in the data. And they can all go back to the same source and not have to dig through the mess in the bronze layer because, as we've established earlier, it's just mostly raw data that's been unfiltered. And hopefully the silver data sets will simplify the data pipeline or the data flow for these business teams so that they can just focus on the analysis that they want to achieve. So yeah, it's great for establishing common ground between teams that have similar goals but maybe have a slightly different focus.
Okay, very clear. So once again, thank you for coming, Marielle. I think it was very insightful for all the people that are going to connect to Data by Design.
Great.
Hope it's going to be always as interesting to have all these different kind of business users asking for data modeling.
Yeah.
And happy to welcome you again whenever you want to talk about another data modeling domain.
Yeah, thank you so much. It's been an honor to be part of this little show, and thank you so much for inviting me. I'm glad that these insights could help you.
Thank you.
Yeah, you're welcome. Yeah.
Bye-bye.
Bye. We made it!